Hello and welcome to another episode of Indiedevs Talk Shop. My guest today is Dennis Gustafsson, known for games such as Sprinkle, Smash Hit, and most recently Teardown. Welcome, Dennis.
Thank you so much. Thank you for having me here.
It's very nice to have you here. So your games, Sprinkle, Smash Hit, and Teardown, I think they're something very interesting about them is how they all sort of revolve around physics, I think.
Yes.
And I think that's true for all of, like, I haven't played any of your games that don't sort of have this physics focus.
There is one or maybe a couple that don't have that much physics, but now since I come from a physics background, that's a very natural place to start. And I also think physics make for a lot of fun in games. It's just the way, when I've been working on physics and tinkering with objects and just this, it naturally leads to a very fun, interactive world that I think games is a lot about.
Yeah, because I think you started when you started like programming more simulation kind of things, game kind of things. You started with you ran like sort of a physics middleware company before doing like your indie game thing, right?
Yeah, that's right. We started. That was over 20 years ago now. Physics middleware startup. I think it was 2001. Physics wasn't that popular back then. It started to come a little bit with the ragdolls in games and the occasional object you could move around. But it kind of intrigued me, and I got interested in just interactive simulation and with a couple of other guys from the education that I was going to. And we ended up forming a company around that and tried to sell that as a middleware. We were young and it was pretty hard. I don't think we were that successful in doing so, but we managed to get acquired by this hardware company, Agea. I don't know if you remember.
Aren't they the ones that made a physics card that was supposed to be like a GPU for physics?
Hardware physics accelerator, which was, I think, not a very great idea to begin with. But there were a lot of problems with that. But that's how I got into physics. And I was mostly working on the software side of the things back then. So I wasn't that involved in the hardware programming or the hardware project, but I got a lot of connections and I got a lot of insight into how physics is made and how it can be used in games. So I think that's definitely where it started.
I think it's so interesting with these physics programmers because I don't think, you correct me if I'm wrong, but it feels like there aren't that many of them, like people who are good at game physics. Because when you go I've tried to implement some kind of algorithms for 3D collision detection, especially also the resolve of that. And I go to these forums online. There are a few where some physics people hang out. And it's quite often, some of the more recognized name that come in and reply. So it feels like there's not a big bunch of people really in that sphere.
Yeah, it's always been pretty small, and I think in a sense it feels like it's almost getting smaller because
what's happening?
Yeah, there was this around maybe 2000. I don't know, was it 6, 7, 8 something? There was this hype around physics. I think was to some extent because of the games like Half-Life 2 came out around that time and people got interested in physics and you started to see more of it. But then it kind of died down a little bit. We never got this physics revolution that a lot of people were hoping for. But yeah, you're right. It's not that many people. The number of tools and APIs coming out is also not that many. There have been a couple of recent ones, but yeah, it's not at all the same interest in physics as there is for graphics. And I don't know really why, because to me, physics is definitely very fun to program and play with as a programmer.
Maybe it's that maybe it's just a slightly harder to get into them than graphics programming, because graphics programming is like, oh, now I have the triangle on the screen and now I can put 2 triangles. But physics is like, it's slightly more broken for a long while until something actually works, because
yeah, there's a lot of glitches you can get if you don't get everything right. It tends to just spread and cause a lot of artifacts. Might maybe be slightly more math heavy than graphics too, but it's actually not that math heavy. So it's yeah, I think it's a lot of fun. I think more people should try it, but there is definitely a lack of somewhere to gather around it and learn from others. There was this forum run by Erwin Koemans, the Bullet Physics forum. I don't think it's a lot of activity there today, but like 10, 15 years ago, that was the place to learn physics. And I don't think there is really a good replacement for that.
And I think it's very funny also with like when you try to learn about physics, and maybe you buy a book on it, or you try to Google around for it. What I've seen quite often is that you get very good information on collision detection algorithms, and then the other part, which is sort of the resolving it and handling the collision, that part is usually less well documented, and I think that's the hard part, is to me at least.
Yeah, maybe it's a lot less code. The collision detection is the tricky part, in my experience, to get right. The resolving is actually, I wouldn't say trivial, but it's definitely much simpler to implement.
You know, I think it's maybe because when you program sort of collision detection resolves, it's the detection you can sort of do, at least in the cases where I've tried it, you can do sort of just do the math and it works out. The handling sort of, I tried to do like, you know, kind of GJKs, this algorithm, and then you have some kind of expanding polyut. I don't know what it was called. But then you have to sort of find contact points over several frames. Yeah. So I think those kind of things where you kind of have to kind of be sometimes with physics a bit more, you have to be very sort of careful and construct it in a very careful way so that the game doesn't just get jittery and break. And I think that might also be one reason why people have a hard time getting into physics, because it feels like if graphic is a bit jittery, then it's fine. You know, that maybe it's even funny. But if your physics is a bit like shaking and being strange, everyone is like, it's not good enough.
Yeah. No, that's a good point. And it's all very interconnected. It's usually very hard to tell if something is jittering around or shooting off into space, or it's really hard to say, is it the solver or is it the collision detection? Is it somewhere in between, or it can be anything.
Yeah.
So it is very hard to debug, I would say, that definitely.
Yeah. So let's talk a bit about Teardown, because your earlier games like Sprinkle and Smash It that you made with under mediocre games, those were sort of more conventional rendering games, using the old triangle and stuff. But Teardown uses sort of voxel rendering. Could you just like give a short overview, or sort of, so people listening sort of knows how it?
You mean about the game or the rendering?
Yeah, the rendering, like what's the use an overview of the difference between using voxels and doing like old school triangle meshy things.
With normal rasterization, you just send triangles to the GPU. It puts out pixels based on those triangles. Whereas in Teardown, it's rendered completely almost completely without triangles. So using ray tracing and marching through these volumes of voxels. So it's basically just looping over the voxels, like traversing the voxel space and see where it hits. And then once it hits, you can also get the information about which direction it's facing and stuff like that. So it's a lot like these ray marcher demos you see a lot on Shader Toy. It's more that paradigm that you basically just render an area of the screen and then you figure out what's in that area, rather than outputting each individual triangle. And part of that, it wasn't always like that for Teardown. I actually started by rasterizing, like triangulating each voxel into triangles and then drawing them with rasterization on the screen using more conventional methods. And a lot of voxel games do this. I think most voxel games actually do this, including Minecraft. Well, it did at least. I don't know what they're doing these days, but
and I think this thing is called, like, you call it a mesher or something when you take that and turn it into triangles.
You mesh the voxel object, and then you, in that process, of course, you can do a lot of optimizations, because if you output like 6 faces, 12 triangles for each voxel, and you have like 100 million of those in a scene, there's going to be a lot of triangles. But then when you do that, you can, if you have a big face with the same color or the same texture, you can just collapse them into bigger triangles or bigger faces. But even with that, you end up with a lot of triangles. And in Teardown, it was quite important for the visual style to have different properties of each voxel. And you could do that by using textures. If you look in Teardown close to the surface, you notice that 2 voxels don't really have exactly the same color. There's always this slight variation. And also in the normal and in the material properties, it's not the exact same roughness on all voxels. And that just made it a bit complicated to get all this information into the meshing algorithm and outputting something that's good. So I just started toying with the idea of tracing it by traversing the volumes instead. And then kind of by accident, I found out that was a much, much faster way to output the geometry to the screen than using triangle rasterization. And then that led to just keep spinning on that idea. I also did lighting the very same way, by traversing voxel spaces rather than using conventional methods. So the rendering in Teardown is very different from most other games in that it's traversing volumetric space rather than outputting or rendering 2D triangles.
So when you do this ray tracing, where is the ray something? Does it output rays from the camera that just go around and bounce, or is it like from the light sources or from the surface? Where does the rays come from? What's the origin of them, and where do they end up?
So it still uses rasterization for that part. Actually, the first primary surface you hit, it's not ray traced, because in Teardown, a part of the style that I wanted was to have oriented voxel objects. That, I think, is what maybe sets Teardown apart from most other voxel games, that it's not just a big world where everything faces the same direction. You still have objects. So if this was a voxel object, you could still like tilt it and lean it and have rotation.
That you can take your car and turn it off axis and turn it upside down and stuff.
Yeah, and that's quite important, because if you want physics, it just wouldn't work if it was in quantized to a world grid. And in order to do that, especially with the hardware at the time and the graphics API I was using, which is OpenGL, or was OpenGL, there was no way to do that in an efficient way, because you can't just query the scene, you only handle one object at a time. So my compromise was to render each object as a box, a bounding box, which contains the voxel volume, and then you can make an intersection test for each pixel of the screen, like that camera ray, into that box to get where it's entering the box and where it's exiting the box, and then you traverse the voxels in between. So that's how it handles the primary surface. But that cannot be used for lighting, because then you would need to render these boxes from every pixel, and that just wouldn't make any sense. So that's handled in a different way.
But you said that the when you moved from the measure style to the using more ray tracing, it was much faster. Is this sort of because of the times we are in with faster computers, or is it also because sort of the trade-offs you did in the rendering that made it fast enough, or like
it's hard to say.
It worked out?
I think it could have worked out with meshing too, to be honest. It would just have been so much more work, because especially in the dynamic world of Teardown, where everything breaks all the time, you need to remesh all the time, and that's quite computationally intensive to do that. And this decision to move over to tracing the voxels volumetrically, it came pretty early. So I can't really say how far I would have gotten with the meshing approach. I think it could have worked. It's not a totally out of the question to do it that way. I think it's a sane method, or was at least. These days, I don't know. It's I think for a long time GPUs were about pushing more and more and more triangles onto the screen, but I don't think that's really the case anymore. Now GPUs are getting much more efficient at just general programming and memory accesses in different ways, which is much more suitable for this volumetric traversal. So I think the way we're heading, it's getting more and more effective compared to rasterization.
And then you have the new era of GPUs, the GPUs with built-in support for ray tracing. Do you use that capability for the game, and does it help?
In Teardown, no. And that is to a large extent because I was using OpenGL for that implementation. And that's just not available in OpenGL. So it was just not a possibility. I should add, though, that just recently, over the last couple of months, I've been switching over to Vulkan, and I have done experiments with Vulkan ray tracing.
I've seen that on hardware. Twitter. I've seen you working on new voxel render with this really nice lighting techniques.
Yeah, thank you. It's so it's so now I actually do the same thing, but with hardware ray tracing. But I'm not tracing triangles. I'm still marching voxel volumes, but I use the ray tracing part to find these boxes. So it's only like for the first couple of levels in the scene hierarchy, and then when I get down to the actual voxels, I still do the same voxel traversal that's done in Teardown. But it's remarkably efficient, actually. It's I was blown away. I never have thought it would be that fast for something it wasn't really designed for.
But I guess that's on ray tracing hardware then, like it.
Yes, so it does require ray tracing hardware.
Maybe that game it would require the actual hardware. But that's, I mean, I think many people have that these days. Initially was this.
Yeah, at the time when Teardown was made and when it came out, I don't think it would have made any sense to require ray tracing hardware. But these days, for something that comes out a few years from now, probably. Yeah.
So going back to the sort of the physics in Teardown. So something that I found interesting was that, say that you you're driving a car in Teardown, you're driving a big truck, and then there's a pipe overhead that you drive under, and you sort of hit a support. So there's a support for the pipe, and you hit that support, so the sort of the pipe above sort of starts saggy, like it starts to kind of fall down, kind of halfway, but then it's like hanging a bit. So it sort of starts to collapse and deform. When you do this kind of voxel-based physics, how does it know when to stop? Like, how does it know how to kind of that it reached an equilibrium? Because
so that is not really related to voxels. It's voxels are used for collision detection in Teardown. So there are no convex objects or anything like that. It's just all little voxels that get tested against each other. But from a dynamics perspective, with these pipes wiggling and swaying, it's just a very traditional rigid body simulation. So there's no deformation, there's nothing like that. It's just all segments with joints in between, and then they are simulated. So it's
like a skeleton, sort of, or like
it's actually just individual objects. It's not even that many, but it still looks convincing. So when that pipe is swinging, I think I know which pipe. Maybe you're like in the first level, you get that it's set up for being, draw the player in to try that. And I think it's just maybe 10 or 12 segments or something each pipe. So it's not that many.
Okay, but so when you have this physics and say that you blow something up, so it's sort of cut off, does it then just break it apart into a new segment? So there's like a little.
You mean for the pipe specifically, or
For example, with the pipe, like if you like blow it up so that there's like a chunk falling off it, how does it like? I guess that then becomes like a new segment.
Yeah. So when you break something, there's a lot of things going on, and that's pretty complex code. But what it does in terms of the pipe, say you have a big pipe in the middle, and you take out the middle piece, then of course these should no longer be connected with a joint. So it knows for each joint which shape it's connected to. And it can, of course, detect that if you take out the middle piece, if that includes a joint that should be destroyed, or if you take out a piece that becomes a new object, that joint has to follow along to the new object. So joints are all moved around as destruction happens, and they can also be destroyed. And there's a lot of things also with light sources, and that tends to change ownership dynamically along the way.
But so say that you have more of a sort of a house or something. Like in the first level, you're sort of supposed to destroy a house, and when you manage to break the whole foundation around it, the whole thing sort of starts to collapse. So essentially, you have a house and you blow out the walls all the way around it, and then it starts to fall over. Is that thing like a single segment without any joints? And
I think the house has a couple of joints. But yeah, it's mostly just a big object, and that's also why you need to take everything away down to the last voxel, and then it falls, which doesn't look great, but but that's just the way it works in Teardown.
But it sounds like it's this. Is it some kind of graph theory thing, like, because so that when you blow out the last piece, it needs to know that, okay, I'm no longer connected to the other stuff below me. For the house, for example, when you blow out the entire foundation around, it starts to fall over. It sounds to me like for a house like that, it could be computationally intensive to kind of check that and get it correct.
And that was a big problem in Teardown in the early days, even during the early access phase when we first released it. I had to set a limit because, as you say, searching knowing whether it's still connected is a very difficult problem, or it's not difficult, but it involves a lot of data. You need to traverse an unbounded distance. Like you don't know how much you're going to search, and it might end up being millions or tens of millions of voxels before you know if it's still connected. And therefore, I put a limit. It only searched. I don't remember what the limit was. It was chosen to include like an average size house in Teardown. So most of the houses would work, but for really large ones, including the main building in the hub,
right,
it didn't work.
Yeah.
And we saw a lot of disappointed people playing it, like spending an hour, like taking out all and then waiting for it to happen. And like, no, there must be something. And then they went around another hour to check if there's actually connected. And that was a lot of disappointment. So I spent a long time actually investigating other alternatives to this naive search, and managed to come up with something that's used today. That can handle all these tricky situations. So now it has a much more complicated algorithm for finding these separated pieces and making it all work. And it's based on it uses previous knowledge. It does require a little bit of a different setup, because if it requires everything to be connected when the game loads or for each level. But it uses that knowledge. Like if you break something somewhere and you knew that it was connected before, you can make assumptions for how long you need to search. It's still rather complicated, but you can do it, and it's that's what's being done. So it uses some coherence or like some knowledge from how it was before to determine the bounds in which to search.
Is it like specially also is it set up in a way that like, oh, I know this is sort of this thing here is a house and we need to have this thing prepared for it, or does it work for sort of anything in the game?
No, it's very generic. It works for everything. So and it doesn't have any constraints other than that it has to be connected when the game starts. If you have a floating island when the game loads, it would, as soon as you touch it or break it with the old algorithm, everything that was floating, it would fall down. Whereas in the new one, if it was floating when you loaded the level and you chop something off, it would still float. So it's not really, it's more like a level design bug in that, or considered a problem in the geometry if it's not connected.
Yeah, because then you've made floating islands to begin with.
Yes, exactly.
So I guess that's fine.
Yeah. And I think at that point, the modding scene had already started to take off with Teardown. So it was quite important that it didn't require any special setup to work. It would need to be very generic and just work for everything.
So speaking of modding, so you have in the game Lua as a scripting language for scripting. How did you end up using Lua? And is modding the main reason, or would you still have it if you didn't do modding?
I would still have it if we didn't do modding. I've used Lua for previous games also. All of them, I think, actually, except for maybe the first Sprinkle, I think, just had a hard-coded logic into the C++ code. But yeah, I like scripting languages. I like Lua. I find it very convenient to write simple gameplay stuff in Lua as compared to C++. So we were just using it for everything, even before modding was a thing. I know a lot of people have problems with scripting languages, or like advocating writing stuff in a proper language for debuggability, and But I don't agree. I guess it's maybe just personal taste, but I like this quick and dirty. Just if it works, just leave it. There might be bugs left in it. There might be problems with it, but if it runs, it works. You just consider the scripting code more as a piece of content rather than the code. And the scripting contexts in Teardown and also in previous games have always been set up so that each script is very, very isolated. There's no way it can touch any other script or modify anything that can affect anything else. So it's and that's why you can treat them like that.
Yeah, but and also like because you have like I guess the reason you can have modding so easily is because you already had this. Because you usually when you like people are, oh, can there be modding, and you're like, no, I wrote my entire game in assembly. I'm sorry.
Yeah.
So I do agree that, and also that it becomes sort of like content because it's something you can just load easily. Yeah. I mean, these days I experiment a lot with this. I'm using like hot reloadable DLLs and stuff that you could load at runtime, and I guess you could do some kind of scripting thing with that where you can load them in. But I mean, I worked on game engines that have specifically Lua as well, and I can see how it is. It is a bit more sandboxed, a bit easier to set up, and it's not gonna blow your program up if something goes wrong.
Yeah. That's also for me. It's a lot about the iteration times. Like even with the hot reloading with DLLs, yeah, I guess maybe you can get it as fast and quick. But that to me is probably the most important aspect, to just get the results immediately and have iteration times really low.
I guess also the with Lua, so with scripting languages like Lua, usually the main problem is to me that you can't validate before running them if they're gonna blow up or not. Like you don't have any sort of compile step and stuff. Yeah. Is there for Lua some kind of validator to like, oh, this code will not crash? Like, you know, it's at least syntactically or correct or something.
Well, it does compile in Lua, so you do get syntax errors and stuff like that, since it compiles to a bytecode. But Lua is very permissive in terms of you can just assign things to variables that don't exist, and it's not a great language for larger scripts, obviously, but I like it for really small things. It's very convenient for me to write Lua. I think it's a really good language actually for those particular purposes. It's really easy to dynamically create data structures, pass them around, and treat them differently based on context and stuff like that, which can be rather hard if using a strongly typed language. But there are some places where it just breaks down. And I don't know if you played the game so far as to see the robots, but there are in part 2, there are these robots with pathfinding, and they were animated, and all of that, except for some core pieces, is done in Lua, and it's one single Lua script that's, I don't know how many 1,000 lines of code, and it's probably still very buggy, and there's just no way to.
Did it become a bit of a monster over time?
Yeah, that's the worst one. And we also do the UI code in Lua. That can also be a lot of code, but for the most part, I'm very happy with Lua. And actually, this thing about analyzing and getting some static error checking, there is a new feature that just shipped. I haven't been involved in that at all, but it's the Lua U, or how to pronounce it, the Roblox adaptation of Lua.
Oh yeah, I've seen it, I think.
It does have some way of doing static analysis on Lua scripts, which is now integrated into Teardown. You can get things like unused variables or these very simple things that can still help, and you get sometimes pretty useful information from that.
Since you have these sort of, well, except for this robot, but since you have like the scripts quite small and they're self-contained, I think that actually solves a lot of the problem that you have with scripting languages. That is, if you have a very spread out, like it touches lots of different files and does different things, then the main problem that I see is when you, unless you have some kind of static analysis, that when you want to refactor code and you just want to rename something and it's used in a bunch of different places, then it's it just, I think for like in compiled languages with lots of static analysis, being able to just rename a variable, hit compile and fix the compilers, and then kind of feel like, oh, this is gonna work, it's gonna be fine.
Yeah,
that's sort of very nice for a big code base, but I guess it works fine for this small separated things.
Yeah, there were remarkably few errors like that when developing the game. I would say I was the sole programmer for a long time, so that also, of course, simplifies things a lot. This I can just keep it in my head. But yeah, for making simple, the game logic in Teardown is super simple. It's usually like, this object should be here, and then you win. Yeah, it's not that complicated. So for those types of goals or setups, or like if you push this button, that thing should turn this joint that much, and I couldn't really think of any easier way to do that than to write that in Lua, or any faster way, I would say. Because you don't really have to worry about types or error checking, or you can just like write up the code, see if it works. If it works, you just leave it and then you move on. And I quite like that.
Do you have a good way to decide like what, because you have your sort of, do you have a C++ code and Lua code, if I'm correct?
Yeah.
How do you decide what goes where? Is there some performance reasons, or is there some structural reasons, or is it just like whatever? It's like by feeling.
Yeah, it was all quite natural. Like the C++ side is more like the engine part, even though it's not really an engine, but all the game logic happens in Lua, and everything that's related to the querying the scene or simulating things is on the C++ side. And there was never really a big problem with that. It just came very natural. But Teardown is also, from a gameplay perspective, it's a very simple game. So I think that really helps. Like if there was like very big, crafting or upgrading trees and stuff, that would have made it much more complicated to write everything in Lua, I think.
The lots of the dynamic stuff in the game is actually the physics in Teardown.
Yeah.
And then the gameplay is usually, I guess, there's a set the scene up in a way that you can do your heist by unplugging this alarm and then quickly running to the like to a few points and then to the exit, right? So, and those things are actually just some triggers and buttons, essentially, right?
Yeah. So the total scripting code to set that up for a typical level in Teardown, it's no more than just a few hundred lines of code. And because it's so simple, like also these missions where you, like the first mission where you tear down the house, you literally have a script, like say within this volume, if there is something above this height, mission is not complete, and when it's below the height, it sets the mission complete flag, and then other scripts read that flag and shows the end screen. And it's like most of the objectives in Teardown can be expressed by just a few lines of Lua code, and that's very convenient, of course.
Speaking of gameplay and stuff, so Teardown started as a voxel physics sandbox that you were like doing, and it was. I mean, I think you put out some early videos where you were just like breaking stuff. But then eventually you needed to put in more gameplay into it. What was the, because I think many game devs who are sort of technical, come from a technical, are technically driven, they will make something that has lots of interesting, like maybe has interesting physics and graphics, and then they don't know how to put sort of gameplay on top, so to speak, of this, and that's sort of where the project dies. So what was your process of figuring out how to put the gameplay on top of your physics voxel sandbox?
That was actually, for me at least, that was a much harder problem than to write the voxel ray tracing and simulation, because it was insanely frustrating experience. It took almost a whole year to come up with this heist, two-phase heist gameplay that the game at least was based around in the initial development. And that was of course combined with also developing the tech to a stage where you could actually make something interesting with it. So I had a colleague, Emil, who was building levels, and we were trying to come up with something while I was doing the technology, and we tried many different approaches with vehicle-based games, stealth games for some reason. We had also a heist game that was it was just a single phase. It was not this two-phase structure that it is. So but there were just a lot of problems with this destructible world because it has so many implications on game design. Like making something a more traditional, 90% of all games out there is get from point A to point B, traversing an indestructible level geometry and being faced with enemies. That's it. And enemies, we could have added that, but that was an early decision to not do that. Partly because I'm not that keen on violence in games. I don't think it's necessary. I think it's sloppy to put it in there just to get a challenge. It's much more interesting when you have other challenges, I think.
It's a fun restriction maybe to start, like, ignore violence. Let's try to at least think of something else. Maybe we can add it in later if it's strictly necessary.
Yeah. But it's also with enemies and NPCs, it just drags in so much other things like animation systems. You need pathfinding, AI. We were just two people at the time, and there was just that was not happening. So that was that restriction. But destruction at the level that we were aiming for, like destroy. I mean, the promise was that you should be able to destroy anything. That also makes this getting from point A to point B really hard. if you can just take down a wall and go there, and there are no enemies, there's no game. You can just do that. So a lot of that didn't work, and trying to come up with these artificial restrictions. So we tried like limiting resources is a very natural thing. And we didn't agree on that. I remember Emil was much more on the side, like we should introduce resource limitations and make it more puzzly. And like, if I have one explosive, we can put it here. And where I was much more of this sandboxy, giving the player a lot of tools to have fun with and and still trying to come up with a gameplay that suits that. And I think we spent maybe half a year doing this, trying different concepts. We didn't find anything, so we eventually split up and just just gave up basically. But then I picked it up on my own after that, and I spent another 6 months doing more prototypes. I had like a survival horror game. There were more vehicle-based games, and then I went back to this heist concept, and eventually found this two-phase setup that solved a lot of the problems. It allowed the player to still have access to a lot of fun tools. You could have a lot of fun. There was a sandbox phase. There was no time restriction. You could do whatever you want. But there was still a challenge to set up the level in a way so that this second phase with the speedrunning posed a challenge. And so that was tricky. That was a hard one to crack, for me at least.
And it's so interesting because there's like a few different things you mentioned that. Like one of them is you discussed this sort of resource management, that should we have that or not? And then I guess you were trying to put some kind of resources into the game that you can find and use or something. But a very interesting thing about the game is that, so you have this phase before you start the timer and you need to speed run. And at that point, you're just exploring the space and trying to figure out how can I set it up? So you actually, in a sense, and this is very genius to me, you have resource management in form of, there is one speedboat here, and I can put it I can put it close to this place where I will first trigger the alarm, so I can run over to this place with the speedboat. So then you have like these physics-based vehicles and stuff that can be used as resources you find in the level. And that's that I guess that.
Yeah, I think adding the vehicles was definitely, it made the whole gameplay so much more fun, because as you say, they become a limited resource, and you also have to be a little bit careful with them, because if you break them, they are of no use. So, but another interesting challenge with this concept was the quick save mechanic, which was very non-trivial to implement in a game where everything is destructible and you still want like instant quick saves and quick loads. Because without that, it just falls apart. There's no way you're going to spend an hour to make one attempt to make the heist.
It becomes a bit too high stakes.
Yeah, exactly. So that was that took some time to come up with a good strategy and implementation for making that work.
How is the quick save? Is it like it knows? Does it figure out all the state to save? Because you have all these physics and you can break things, and you know, it's just
you can just deform the whole space into something else, and then the quick save should still preserve all that. And I went through different ideas, like should I make like a state log? Should I try to save and make save all the actions and all the objects? And but I ended up implementing a solution where I just serialized the whole level into a big binary chunk, which initially was close to 1 gigabyte for a level. But I added some simple compression, like run length encoding on the voxel objects and stuff like that, to get it down to maybe, I think it's maybe around 50 to 100 megabytes for a quick save, which is still a lot for a save game. But it includes all the state of the level, so you can do whatever you want, and it's still gonna load and save.
And since your gameplay code is simple, that part isn't the big problem. Is the destructible world and getting that correct, right? Because you can you even quick save after you trigger the alarm, or is it just up until you trigger that?
Well, in theory, technically you could, but we don't allow it in the game because we still want that nerve. Like it should feel like you're.
It's just 60 seconds also.
Yeah, exactly. And yeah. So that was an interesting challenge. And since at that point there were no scripts. And that's also a little bit why it took me so long to add Lua scripting.
Oh, you didn't have it initially?
Not when I implemented this quick save mechanic.
Okay.
But then I just didn't want to go through all the hassle of adding Lua scripts, because I knew that when I did, those were going to have to be in the quick save as well. And it's not trivial to make that all work, because you need to save all the Lua state in the quick save files and make that all with all the resource handles and everything to make that work correctly. But I did a very relatively proper implementation of that. There were no like hacks to make it work, which is good because of the modding. For the modders, when they make their own scripts, it all just relies on this automatic state realization with Lua. So I think it was a good decision to make that properly.
I think I read something. I read a bit on your blog, the Lua stuff, that because in Lua everything is sort of tables, and you just iterate over the global table and just serialize it all.
Yeah, exactly. That does have some implications, like you can't use closures, and like if you put functions and like create code, and it all gets pretty messy if you want to serialize that part as well. So I don't do that, but I don't know these days. Maybe it has been added. I haven't been that involved in the latest developments of Teardown recently.
Okay, so is it, at least you're not sure now, but initially was there kind of like for modders who want to write their own scripts, was there like, don't do this because it won't work, like don't use closures, it's not gonna work? Yeah,
there's still some things like that to make it work with quick save, but but it's also the API in Teardown, the Lua API, was deliberately designed to be not using any exotic features of Lua. It's like a very very simple C-like interface. You pass everything in and out as native Lua types. There are no meta tables or any exotic, no like this, no objects in Lua or things like that. So it kind of encourages people to write very simple code to make it easy for and accessible for beginners also. And that just happens to coincide with these restrictions with the quick save. So
nice.
It usually works out fine.
All right. So we're closing in on an hour, but I have one more thing here I was wondering about. So I read on your blog, let's talk a bit about marketing.
Yes.
I read on your blog that when it comes, like you were talking about like giving advice to people, and like we've talked about this show before, that usually it's hard to give advice to people how to get into game dev because the conditions today are not the same as when one starts out. So we can let's not talk about that. But at the end of that, you talked a bit about marketing and that, and these are my words, that perhaps indie devs are a bit obsessed with marketing, perhaps for the wrong reasons sometimes, and almost make it seem like marketing is almost more important than the game. And so what's your sort of view on the importance of marketing?
I'm no expert in this area, obviously, being a more technical person. But for me at least, I never spent, I don't know, I wouldn't say any time, but almost no time at all thinking about marketing, and try to come up instead with something that looks unique, that you can make fun videos of, or like that, something that appeals. And there's no question marketing works, but I think marketing works if you have a big budget. Like if you're an indie dev or want to make something small, spending so much money on marketing that it actually works is not an option for most people, I would say. And I think people overestimate the impact of these tiny marketing you can do as an indie dev. I think that time and effort is better spent making a better game and hoping that people will like it enough to share it with other people, to want to spread the word and to actually like it.
So I guess most the things you did for Teardown was usually just posting clips on Twitter, and then it's sort of
and there was no. I didn't even have the. I didn't even consider that marketing. I was just doing it for fun, and it was actually essential, I think, to keep me going through that year of trying to come up with a game. If I hadn't gotten any feedback from people who actually believed in it and wanted it to happen, I would probably just have given up as well. But it definitely worked, and that was because, of course, it stood out from the rest. Like it looked like something different, it played like something different, and that, I think, just triggers something in people to want to share that, to want to talk about it, to be interested in it, and that as an indie dev, there's a real opportunity there to do something experimental or something that stands out, because the big companies are never going to do that. They don't want to take that risk. So I think that's the best chance you have as an indie dev, I think.
Yeah, indie developers, one of their main resources is their ability to be unique and try something different. And I think like there's essentially two things here. Like if you have something that is very creative and unique, like it stands out, and if you combine it, like if you only have something that's very unique and you put up a video but it doesn't like look nice and snappy and fun, then people might still ignore it. But if you manage to also maybe put in some nice graphics or somehow just make it interesting in a visual way, like we have games like Undertale that is sort of this little role-playing game, and it has a very unique style in that it's very, how to say, whimsical, but the graphics are quite simple, but it's actually it's still very fun to look at, and it just needs to be fun to look at, I think, and be unique, and then it can sort of catch on to people. And then you use, like you say, like, because I think when you have something like that, the important thing is not that you do the marketing, is that your game has some kind of marketability, so that
exactly.
If you if you post something and it fulfills the uniqueness and the visual niceness, something, then it has high marketability, and then your easy sort of marketing
exactly
stuff will work a lot.
And I think a lot of indie games that fail maybe give up on that a bit too easy. Like if you publish something, if you show it to a lot of people and you don't get this response that it has something, that people get excited, it's in many cases, I think, not really worth pursuing. If you want it, I mean, you could do it, of course. If you just want, if this is the game you want to make, you should do it, of course. But if you expect and if you're hoping for a big commercial success, you should be able to judge that by the reception when you show something. And if you don't get that, maybe it's better to keep working and and try polishing it until you get that reception before releasing it. And
you mean that you have your game and you're trying to show it to people and you give up because they didn't.
No, I mean, I think some people or some developers are maybe a bit static. Like you show something, but you don't really take in the response, or you don't really evaluate the response. Like if you don't get these people wowing and like get really excited about it, it's maybe worth changing direction, or like it's if you want a commercial success and you didn't get that response as an indie dev, I think it's not going to go so well. Because if you don't do marketing, you can't just hope for people to find it without having like an audience that really likes it, or some platform holder that really likes it, or some people that can help you with this, getting it in front of people. So maybe this didn't come out very well. But I what I'm trying to say is that I think you can, when you show a prototype to someone and you don't get that really genuine excitement, it's probably not going to work unless you spend a lot of money on marketing. So that's you can get very early signals whether it's going to work, I think, or not.
Maybe sometimes there's like say that you have your game is very unique and you show it to people and you don't get any response because maybe you need to do something like, different games have different sort of some games maybe need to have slightly more polish to the graphics, and maybe you didn't have any maybe it's like an atmospheric game and it needed some music and stuff to kind of get that combination of feelings going. And I guess in that case it can be a good idea to, like, I think you have to know what kind of game you're making also, so that if you're making a very gameplay centric game where then maybe it should be very easy to tell even without all the polish in the world from if it's fun. But if you're making maybe sort of more what I sometimes call a production value game, then it's a bit more tricky to know if you're on the wrong track. But indie devs tend to not do those as much, I guess, also. The production
and I think
value
in my favor during my career, since I'm not really a gamer, I wouldn't consider myself a gamer. I don't like these very systemic, complicated games that takes hours to get into. I tend to like to play more atmospheric or very easy to learn games, and more maybe not casual, but simpler games. I don't have any desire to develop complex games that are that don't have an instant visual appeal, but rather an appeal from a gameplay perspective. And that obviously helps if you want to show short clips on Twitter. It's going to be more interesting with physics and explosions and nice voxel graphics than like an upgrade tree or something for most people, I think. So that definitely has worked in my favor, I think.
I think it's very hard if you do like a big strategy game with lots of menus and stuff to sort of show that off early and get people excited about it. I think that's maybe some of the trickier games to make as an indie dev. The more direct and sort of the more simple and more graphical your gameplay is, the easier it is to gauge if your marketing efforts are if it's marketable or not. But it's very hard to do that for something complicated.
And it's probably very different for different types of games, how you can market and especially how to judge whether it is marketable or has this appeal or not. I guess you would have to do a lot of playtesting for some games.
When I was trying to show my game to, like, I was posting my game Cat and Onion that I made on Twitter and stuff a lot. And that game is sort of, it's a bit atmospheric. It's sort of like an adventure game with all these things. Like it's sort of a game where initially when I showed it, I redid the graphics at one point, and I also didn't have music. So before I redid the graphics and had music, nobody really cared about it. But then I didn't like, I think when it started, people started liking what I posted was when I started liking the game myself, because at some point I was like, oh, it's the game, the graphics are too dark and it's too noisy and there's no music and like stuff like that. And I want trying, to tell a little cute story. So that was sort of missing from being able to show people that there is a cute little story going on here. So when I added that, then people were like, oh, this looks nice. So it is hard to gauge when you're but I think if you're making something that's very gameplay heavy, if both has simple gameplay and the gameplay sort of is supposed to be the main thing, it's not sort of an atmospheric game, then I think then you can judge it a bit earlier maybe.
Yeah. That thing you said with the music and these little detail is something I've also been struggling with a lot in the past. Like if you want to judge, if you make a prototype of something, to just for yourself judging if that is fun or not, for me is very hard without having the things that make it nice and fun, like music, for instance, or nice sound effects, or just polish to the UI, or I think a lot of other people are probably better at that, but for me it's really hard because there's so many of these little subtle things that just makes the whole difference, and that I think adds a lot to the frustration for me to do prototyping for games, because whatever I do, it just doesn't feel fun. And I keep searching, and then eventually when I'm the most fun I can get, and then it doesn't actually get fun until I add all these little polish or add the final touches to it.
Can I ask, like with Teardown, when did you feel like Teardown is fun, like as a game and not as a sandbox sort of? Did you have a moment
I don't remember exactly, but we did show. I went to DreamHack in 2019. I think it was about a year away from release. It had one heist mission that people could try. And I spent a lot of time leading up to that, spending maybe a month polishing out, making a UI and adding some music to that. And that's probably the first time it felt really fun, like it was an actual game, and I could enjoy it.
I guess it sort of started to come together also as a more cohesive experience then, because you did all these polish things.
Yeah, exactly. And it's but it's hard. You can't add polish and all the things to every prototype to judge it.
No, so then you run out of time.
Yeah, exactly. And it's that's a struggle for me to try to, in my head, like add that as a layer on top of this prototype that looks terrible and it's rough around the edges, and then trying to think what would this feel like if it was actually nice and polished. But I guess maybe that's something also that comes with practice. I don't know.
Yeah, I think something that you talked about before with when you talked about figuring out the gameplay, I think what you essentially maybe did was because you tried to add on all these things to the game to sort of make it fun, but eventually maybe you figured out some simple gameplay that plays to the favors of the things that are already there, and I think that is when you find that and you put it in, and it both sort of, it feels like it almost the gameplay you figure out sort of simplifies the game in some way. Like it instead of being more complicated by putting it in, it almost felt simpler because it sort of explained why you were doing these things. Why are you blowing up? Why are you breaking the house? Because I need to demolish it. And I think at that point, sort of, at least for me, that's sometimes when the game starts feeling a bit more fun to me as a developer, when I had this clarity, like I don't need to put all these complex things that I worry about so much in. I can do this simple thing that fits very nicely in.
Yeah. And I think being this thing where it's hard to judge a prototype before it's polished could also be a strength, in that you keep searching for a better gameplay until the gameplay itself is at least a little bit fun without the polish. Whereas if you it makes you more picky, I think, on selecting the right gameplay.
Yeah, I think it was, I watched Tim Kane's YouTube channel, the guy who made Fallout 1, and he said something like, one of the hard parts of game design is not coming up with all the ideas and sort of making the systems. It's knowing when you get an idea, knowing if it's a good idea for this game. Like it can be a good idea for some other game, but this is a good idea for this game in particular. Yeah. Does it fit in with this game? And you can usually, if one is a more junior game designer, you can sit and you can go with something that's perhaps not a good idea, and then you will notice that, but it will take you 8 weeks, like 4 to 8 weeks, like it will just take forever, and suddenly you'll be like, this is too complicated, and then you sort of rip it out, and maybe at the end you sort of have something simpler that has just a tiny fragment of that idea. But in any way, it's sort of I think that's actually the hard part of game design, figuring out figuring out which ideas are worth pursuing for this in particular, exactly. And then going deep into those.
Yeah, and I think it requires pretty strong direction. I tend to like games that come from a single mind, or like that has strong direction from one person, because I think that's it's really hard to make a cohesive experience if there's a lot of people involved in it. And with more like a democratic, like I want this in, then maybe I should throw this in, and it makes it really hard, I think, to make everything come together if there's just too many ideas are mixed together.
Yeah, I think the bigger your team is, the more you tend to maybe gravitate a bit towards these production value games. You have games like Red Dead Redemption 2, GTA 5 and stuff, which have lots of interesting gameplay, but it's not focused sort of around the core as much, and it doesn't feel like someone has been worrying for a year trying to figure out exactly how to make this thing in the middle fit. It's sort of just like add in things from all the directions until the player just, like, if you play GTA 5, you probably only play 50% of the game, because you don't even notice many of the things that's going on, because it's just like you find your own game within the game. But that's not possible for an indie dev to do, because there's no time. And
exactly.
Anyways, I think that's we was going to do an hour. We're a bit over time. But that's fine. Just quickly, like, what are you going to do now? What's coming up in the future?
It's a good question. I started tinkering with this Vulkan hardware, ray tracing, and voxels, and I am not so much actively involved in Teardown anymore. I moved on to looking for new things. Whether parts of that ends up in Teardown or a new project is yet to see. But now I'm in experimentation mode, which is super fun to be back at, because I haven't been in that mode since before Teardown. So it's really fun to see all the development in technology that's happened since that was 2017, 18 last time. So I'm trying to catch up with that. I have a lot of ideas. It's probably going to be still voxels. I feel there's more to do with voxels, or at least alternative representations. I don't see myself making, a game in Unity using animated meshes and NPCs, and it's just not that much in my interest. So it's going to be something, just experimenting with new stuff, new ways to do things, involving both simulation and rendering. And I don't know, when it comes to game design, I'm not sure. I think it's fun afterwards, but I kind of hate it in the middle of it, because it's just so much frustration for me. And you're just torn between these like euphoric moments where you think it's fun, and then like the day after, maybe it's not fun after all. And then it's just tearing me down a lot when I'm in that state. So I'm maybe not gonna try to do that for the next project. I'm hoping to get someone else to do game design.
Yeah, maybe you're a bit you're scarred from the 1 year of figuring out Teardown.
Yes. Exactly.
Okay, but yeah, thanks a lot for coming here and talking about everything game dev.
Yeah, thank you. Thank you so much for having me.
I will see everyone around. Thank you all for listening, and thank you again so much, Dennis, for joining.
Thank you. Bye-bye.
Bye-bye.